Alright, before we go any further, let's summarize what we have learned and make sure we're all on the same page. In the last example we did together, the setup function, we declared 3 different arrays. Each of these arrays was declared in a unique way, in a different way. So that means we have 3 ways that we can declare an array. Now I have written them down here so it's clean and we can look at them and study them and make sure that we understand what they are. The first array, we declare an array and allocate new memory for the array, hence the new operator. This is number 1. Number 2, in number 2 we are initializing our array. So in number 2 we declare an array and initialize the values of the array. So in the first method we initialize everything to 0. Here we initialize them to a set of numbers. We initialize the values of the array to set of values, which has been given to us here. The third way, declare an array and we don't initialize or allocate memory. So it's basically an empty spot in memory. It's pretty useless to us unless we allocate memory to it. Now this is quite interesting. So right now I could reallocate the memory that has been allocated to X, to Y, to Z. So right now I could go ahead and say, for instance, Y new int 5, and we showed what would this look like in memory. However, please pay attention that this is initialization, so I will not be able to do something like this. This is okay. I will not be able to say, for example, Z equals 1, 5, and 10. I will not be able to do this. Right? So this is assigning a whole bunch of values to an array. Only works when the array is being initialized. You can't declare an array and halfway through your program decide to initialize it like that. That will not work. You can reallocate the memory and an array of zeros will be assigned to that variable, but you will never be able to initialize that. So if you wanted to initialize an array, you do it at the very beginning. Now, strictly speaking, for the most part, initializing arrays is useless for the most part, because you typically have an array and then you would read in values from a file or something like that we're going to do in a near future. But it is possible to initialize the array values like this as well. So you can play around with some of these things in processing and see that it wouldn't work. Another thing is that if you wanted to change the value of any of these, you just use it. You just do it using the square bracket operators. So, for example, if you wanted to change the second value of x, you would just do the index operator. So hopefully we are all on the same page. Now, fortunately for us, arrays are quite sophisticated and they come with their own functions that we could use, and they come with their own set of variables. So if you look on processing.org on the reference side, you see a whole bunch of functions associated with arrays. And just a note, arrays are different from array lists. So we're not doing array lists, we're just doing arrays. So if you go over to arrays, and you see a whole bunch of functions that exist for arrays, and I want to talk about a couple of them. The first one is actually a variable that's inside an array. So an array keeps track of the length, much like the string, except the syntax is a little bit different. So for instance, if I go back to my example here, if I have x, and x is, so if x has 3 elements, if I say print ln x dot length, notice I do not need the open and close bracket here, so it's just length. So it's not a function, it's a variable. Dot length, this is going to output 3, right? 3 is going to be outputted to the screen simply because that's the length of the array. So if I wanted to print out all the values, so let's see how this is useful. Let's say I have int x new, I'm missing the int again. So in memory, I'm basically getting something with 10 spots, right? If I want, and this is all 0, so this is index 0, index 1, index 2, index 3, index 4, all the way, and the last index is index 9. And they're all filled with zeros, right? If I want to initialize, if I want to change the values and I want to put the value 5 in each cell, what would I have to do? Well, the easy solution is to visit each cell and assign the value of 5 to that cell. How would we do this? We would do this using a loop because we don't know how large an array is. So we could do it this way. For example, I'm going to do it using a for loop. So I'm going to say for int I equals 0, I less than x dot length and I plus plus, and I would just simply say x index I equal 5. So what this is going to do is going to go through index 0, it's going to set index 0 to 5, then it's going to go to index 1, set this to 5, then index 2, set that to 5, 5, 5, and all the way to the end goes 5. Don't forget, this is the case again. If I would have said I is 0 and I less than and equal to length, what would happen? This is really dangerous. This would be an out of bound error. In processing, this is not so dangerous because the compiler catches this for us. But if it didn't, your program would crash completely. So that's why you want to go less than, because you never want I to equal length. Because if I equals length, that means I is 10 and length, because length is 10 and there is no index 10. So that's what we would do in order to populate an array full of values that we want to have. All right, let's consider some of the other functions. So there are a whole bunch of these, and I'll leave it up to you to go ahead and see what each of them will do. So for example, let's pick one in random. So sort will sort an array. So if you have an array 5, 1, and 3, it'll sort the array in order from smallest to largest. Reverse would reverse whatever array you have, and so on and so forth. I would like to go over a couple of very useful functions. Not that the other ones aren't useful, but these are in particular I wanted to go over, are append and shorten. So if you have an array R1 and you have 11, 12, and 13 inside, so this is R1, and we have 11, 12, and 13 inside. This is index 0, index 1, index 2. If you call the append function, the way you would do that is you would say R1 equal append, and as parameters you need to pass in the array that you want to change and the element you want to add. So this is going to add an element at the end of your array. So here R1, it's going to, so 14 is going to be added, and now this is going to be increased in length, right? The shorten function, it works in reverse. So here I am giving it an array to shorten. So if the array is R1, 11, 12, and 13, 0, 1, and 2. When you say shorten, what happens is it's going to take out the last element, so it's basically going to pop it off. So now in memory, R1 is going to be 11 and 12, right? So one thing you have to realize though is that the array that you send to it could be different from the array that is catching the return value, right? So this is going to take an array, take one element off from the end, and put it inside of R1. So let's do an example. I'll let you know what I mean. Let's do the example on processing. So if we have, let's say we have int array x, let's say this is going to contain 11, 14, and 17. And we're going to have another array y, and let's just say that's y. Let's output both of these arrays. So I'm going to say println x first, and then we'll say println y. Let's see what this is going to print out. So, oh, sorry, I forgot the semicolon. So this is going to give us an array. It's not allowing me to output y because y has not been declared. It's just a dot in memory. There's nothing to output. So I'm going to comment this out, and I'm going to print x. And in x, you see that you have 11, 14, and 17. Now, if I do this, if I say y equals shorten x, what am I saying? I'm saying take one element off from the end of y, from the end of x, and then copy that into y. So let's see how this works. So here I'm going to say println y is, so we know that y is starting from here. There we go. So we have x to be 11, 14, and 17, which it was. Y is gonna be x, but 1 less. Let's see how that works in a memory diagram. So if we have setup, we have x, and x is 11, 14, and 17. Then we have y, which is a dot, and I'm saying y equals shorten x. So shorten x is going to take x, it's a predefined function, right? So it's not a user function. You can write a function very similar to it, but basically what this does is it's going to take x, take 1 off of x, and then copy the result into y. So when you copy the result into y, you'll have 11 and 14, right? So the note here should say this line takes x as input, takes one element, actually I should say takes off the last element of x and copies the result into y. Okay, if I actually just want to shorten x itself, so if there was no y in the picture, at all, and I wasn't interested in y, but I wanted to shorten x itself, then I need to say x. Then let's do this. I would say println x originally was, and I'm gonna print what x originally was. I'm gonna just take off y here so it's not busy. So let's print ln x. What was x originally? And then here we say println x after shorten is called. So when I call shorten, what do I need to do? Shorten is going to take x as an input. It takes off the last element of x and copies the result into y. So we don't have y anymore. It needs to copy the result back to x. So now, if I run this program, originally x is 11, 14, 17. After shorten is called is 11 and 14. So it takes off, it pops out the last element. So shorten, when you call shorten, 3 things happen. Number 1, you take x as input, so you take an array as input. You take off the last element of that array. This is number 2. This is the second thing it does. And number 3, it copies the result into this receiver array. which could be the same array, right? Let's do the same. Let's do an example for append, because append does the same thing. And let me do that example on here. So if I have void setup and I have int x equals new, well, actually let's just initialize it. 11, 12, and 13. So in memory, so it doesn't matter how you draw your array. You could draw it upside down or horizontal or vertical. It really doesn't matter. So that's what this looks like right now. We have 0, 1, and 2, 11, 12, and 13, and this is x. Now, if I want to append, so if my goal is to append, let's say 14 here, if this is my goal, I would basically have to say x equal, and I would call append, and I would send append x, and I would send what I wanted to append to x. So this is going to take x, it's going to add 1 to the end, and it's going to copy the result into x. So this is what we get at this point. If I have this other array, if I have int y, let's say like that, and if I said y equal append x and 15, this is going to take x, add 15 to the end, and copy it into y. So we have y as nothing. This is going to take x, so that's x, add 1, add 15 to the end, so we're going to have 11, 12, 13, 14, and 15. And so you see 15 is added to the end. Let's do one more line of code. What if I have a null array like this, such as z? So z in memory, let's in memory, this is what z looks like. So if I go like this, z equal append, and I'm saying append and 100. So this is, what am I saying in English? I'm saying take z, add 100 to it, and then copy that into z. The reason that wouldn't work is because z is nothing. So it can't take nothing because there's nothing in z. If there was anything in z at all, if there was any elements in z at all, this would work. So this will not work because there's nothing in z. If I went and said, you know, instead of saying take z, if I went and said, you know, take take y and add 100 at the end and copy to z, that would work fine, right? But if I said copy z, it simply wouldn't. So hopefully that is making sense to you. Just before I finish, I'll do one more quick example here. If instead of this line, if I put something in, actually, let's see. Let me do this example. If right now, if I said y equal new int 3, what happens is what I have in y is gonna be destroyed. This is gonna go away, so I'm just gonna erase it. And what you guys will end up is, what the computer ends up actually, is 3012. So it's going to end up, this is the array that y holds now. So hopefully this is making a lot of sense. We'll come back with more material. Thanks.